So this is my cat Sawyer. It's a male cat, ragdoll, who is usually interested in looking at everything that I'm doing and jumping in videos. So we are trying to keep him away right now. This is probably harder than an exam problem. I doubt you'll have an exam question with so many nodes, but you could get it with half as many nodes. And I hope to show you problems in class that are harder than the exam, so that on the exam it's much easier for you. So first let's notice that none of these loops are closed. So if I look around here, this almost looks like a close. Actually, I had shorted this, but I opened. So 1 and 2, Sawyer, seriously, no, 1 and 2 are open. Okay, obviously. And now we're gonna try to find voltage differences within this circuit. So I apologize for this moving all around. And I'm gonna also upload this one page to Blackboard so you have an idea on how to play with this. So we're gonna do almost exactly what it says here. For every Vx and Y, I'm gonna think that the Vx is my plus of the multimeter, and the Vy is where I'm putting the black side of the multimeter, it's the minus. And I'm gonna go from X to Y. I'm gonna trace a path there and add or subtract voltage values according to the polarities of voltage supplies. So I'm gonna start off by, for example, doing N through I, and let's say I is gonna be my positive and N is the negative. Vin, in this case, will be Vi minus Vn. And I'm gonna think to myself, here's a positive, and I wanna go all the way to N. So I'm tracing a path that's like this. And so I will start with this -3 will be my first number, but that's the number on the power supply. But it turns out this power supply is turned in a way that's the negative is the first thing that I encounter when I go along this path, so I'm gonna use that minus. Now this resistor here, because it's in a in the middle of two other resistors, I can even add these two. Let's say if I had R1 and R2, I was going to add the 2, but what happens is the I is a node that's not connected to anything else, to no other branch. So I can guarantee that the current here is 0. So I can guarantee that the voltage drops here are 0. And then I get to this battery, and however many lines you see drawn for a battery, know that it's just a way of drawing batteries. And this here, the big line is the positive, the small line is the negative. So I'm encountering the positive first, so I'm going to call this +2, and then I get to N, so that's it. The answer for Vin will be 5 volts minus -3 plus 2. We're going to do this for something possibly a little bit harder. For example, V1, 2. So if I just put the multimeter between V2, 1, for example, I'm asking what's V2 minus V1? And I'm going to go around a little bit faster here. So I'm going to go along this path. The same thing happens with these resistors. They are not hooked up to anything. But you see I'm going by these nodes like 7, Z, and this other resistor here. So I'm going to jump over thinking there's no voltage drop here. 0 plus 0 plus 7 plus 8 plus -7 minus 6 plus 0 plus 0. So this is V21 will be 7 minus 7, 8 minus 6 is 2 volts. If I had asked you for V1, 2, and you had just gotten V21, oopsie, you could just say V1, 2 is minus V21, which is minus 2 volts. I hope this helps with voltage drops or any voltage drop questions on an exam.